Good morning, everyone. Welcome to this webcast. We're glad you're joining us for CSU Major Institutional Grants. I'm your host, Jennifer Wicks, as we come to you live from Central Station U Studio here at the Office of the Chancellor. We'd like to take a moment to check our footprint savings after we just take a brief look at the polls that you filled out on the screen so far. Are you planning to apply for a grant? It looks like most people joining today are in fact saying yes, they are. And which campus are you joining from today? Looks like most campuses across the system do have representation in today's session. Feel free to share the link with colleagues you may think have an interest in this particular topic as well. We can post that into the chat pod in just a moment. So let's take a look now and update our location as we take a look at our footprint savings for how we're offering today's session as a virtual webcast session. I'll send a note to your computer. If you could just type in your zip code, you'll see on the left side of the screen an option to type in the location for where you're joining. The zip code really is all that we need for this. Most likely your campus location, and then dial in the number of attendees if you are in a group today. Dial it up starting with the number 1, and then update map and save and close. And that will bring us all back to the main savings number that we're accruing through using this virtual session today. As you can see, we're saving over 30,000 pounds of CO2, whether you would fly or drive to us here at the Office of the Chancellor, over 30,000 US dollars, and over 60,000, now over 61,000 round-trip miles. So thank you very much for updating your locations. We can get a nice updated capture of the savings for today's event. I'd like to introduce our moderator today, Dr. Frank A. Gomez. He is the Executive Director of STEMnet here at the Office of the Chancellor.
Before we begin, I'd like to start off by hoping everyone is well and safe. During these times of national uncertainty caused by COVID-19, while there are some who may disavow the magnitude of the problem and science thereof, it is important that for those who understand both, that they be a calming voice to the nation. We have an opportunity to be a participant in educating our students, families, and others to minimize the social and economic impacts of COVID-19. I encourage you to go to the CDC website for more information. So let's begin. Today we bring together exemplars from the CSU community that reflect some of the very best in student and faculty research and educational programs. Institutional grants have the potential to be a major driving force in systemic change on university campuses. Oftentimes involving faculty of the diverse disciplines, they can instill a broader sense of purpose in an institution by allowing for examination of scientific problems not previously imagined. To be successful, these projects involve a culture of collaboration and freedom for students and faculty to explore in interdisciplinary settings. Having personally been a PI and co-PI on several institutional grants, it is amazing to witness firsthand the growth in research capabilities on a campus and how these grants can be leveraged for even greater funding and opportunities for students and faculty. Before we begin, I want to remind the audience to use the open chat box on their screens to type in their questions. Our speakers, when not presenting, will respond in real time. So let's begin the presentations with Kimberly Cousins and Timothy Usher from CSU San Bernardino. Kim and Tim are PI and co-PI respectively of the CSU-SB NSF-funded CREST Center for Advanced Functional Materials, Phase 2. Kim and Tim, the floor is yours.
Hello.
Good morning.
Good morning. Let me first start by saying thank you to Dr. Gomez and his team for organizing this webcam conference and also inviting us to participate in it. We are the CREST Center at Cal State San Bernardino, and we have lots of collaborators all throughout the United States. This is an interdisciplinary effort on the campus of Cal State San Bernardino between physics and chemistry, and involves John Zane, Kim Cousins, Doug Smith, Paul Dixon, and Sarah Calori is our newest member to the team, and I think is an excellent example in which institutional grant can be leveraged to recruit very talented faculty members. So we're in our first CREST grant. We're just finishing that up, and we have our second CREST grant just beginning. And the basic idea is to increase the research capabilities of minority serving institutions. We built our way up to this institutional grant with smaller grants from sources like the Department of Defense and also NASA. It is a very interdisciplinary project, and having served on review panels for other CREST grant proposals, that's one thing that I noticed is that some of the proposals seem to have taken somewhat unrelated research projects and sort of jammed them together and put them under a CREST umbrella, and that doesn't work as well as one like ours. I think one of the great strengths of ours is that it is inherently a interdisciplinary effort and requires a large number of people. The vision statement, I'll let you read that at your leisure here. We've got lots of activities going on here, and with CREST 1, we started out with organic ferroelectric materials, and we expanded into inorganic materials and thin films, and now we're expanding into applications of these functional materials. Our core strengths and our core capabilities of our research center involves computational, synthesis, and experiment, and we work really well together and have integrated all of these. The research occurs throughout the calendar year. Our most productive time tends to be over the summer. We invite a wide range of people to participate in the research, including community college students and high school students through the Upward Bound program, and that works really well for a number of reasons here. One novel aspect to our program is the winternship aspect here that's going on at the community college here. And we have lots of people coming and going and participating in research. We have students going to our partners and also students and people, personnel coming from. And we've increased our research productivity in terms of numbers of publications, in terms of grants as well, and also we're building capabilities in terms of producing new materials, in terms of crystalline and also thin films. And we also conducted a needs analysis, and it turned out positive, and so we're going ahead with a master's in materials science. And as Frank said, the institutional grants are a great way to build on to the grant, smaller grants, including major research instrumentation grants, STEM grants, and a number of other things. With that, I'd like to turn it over to Dr. Kimberly Cousins.
Thanks, Tim. So really, students are a major part of our program, or the reason for being and the end result. We've had 118 undergraduate participants and community college students and high school students to date. We also have 74 graduates already of our program, with 36 enrolled in graduate programs. We've learned a lot of lessons, and you'll hear this also from the next speaker, but administrative support is absolutely essential to make a program like this happen. In particular, we need both buy-in from the administration as well as support staff. Collaboration was really important in terms of both our progress in our research and enjoyment in how things work. And our students, who are a major both product of our program and participants in our program, there is a trade-off we learn between encouraging good students to reach out and take other opportunities and our own research productivity. So we have recently been awarded CREST Phase 2. This is a new competition, not just a continuation of funding, so we had to expand our research focus. We are working on new hires in chemistry and physics to expand our team, our MS program. We currently have an NSF IRIS, International Research Experience Program proposal pending, as well as an MRI pending. We added new collaborators for our CREST 2. That's part of our expansion. And we continue to seek individual and group support for our research. So collaboration is really rewarding, it is really productive, and it's one of the ways that you can get research done in the CSU. Institutional grants require both faculty champions and administrative support. Programs like CREST are life-changing for the students and the faculty, and institutional change is a real key component, and things that we're working on, particularly with CREST 2, is how we can continue in the system or to improve. With that, I'd like to introduce the next speaker who will continue to talk about the CREST program and how they did it at Cal State LA, Arturo Pacheco-Vega.
Also to Frank for the invitation to join this webcast. The CREST Center for Energy and Sustainability at Cal State LA is a collaborative effort with COPI, Femin South, Frank A. Gomez, Matthias Selke, and Women South. The center is now in the second phase. We have had two periods of funding, each one with $5 million. So we're in the second phase. The first one was 5 years plus 1 year no cost extension, and now the second started in 2016 and is going to end in 2021, with possibly going into a 1 year no cost extension as well. As Kim and Tim mentioned earlier, in alignment with the goal of NSF for CREST programs, which is to provide support to enhance research capabilities of minority-serving institutions via centers that effectively integrate education and outreach, and also because of the development of sustainable energy is of national importance, then the mission of this center is to conduct transformative research to promote energy diversity, efficiency, and sustainability while training diverse and talented engineers and scientists that will promote change in this field. Phase one of this center was focused on 4 different trust areas: proton exchange membranes, fuel cells for portable electronics. Then the second, the design of materials for photovoltaic applications. The third one, the study of combustion systems and processes in order to decrease greenhouse gases. And the fourth one, carbon sequestration, in order to develop strategies to minimize essentially the carbon footprint. In addition to the 4 trust areas, we had an education and outreach component with the goal of developing a comprehensive education and outreach activities in order to expand the presence of students historically underrepresented in STEM. And the number of faculty in phase one was 13 across 2 colleges, the Engineering, Computer Science and Technology, and the College of Natural and Social Sciences. In addition to the main grant, the CREST had awarded 3 supplements, each one $100,000 for each one of those components. And what I would like to highlight is the modeling and simulation component. I would like to highlight that one because that component became a standalone component of the CREST Center, and with the idea of essentially providing support to the experimental work done by the other 4 components in terms of mathematical modeling and numerical simulations. Now, as for phase 2, the focus is in 3 research areas. The first one is the development of more efficient paper-based and thread-based fuel cells and batteries that can be used for portable electronics and point-of-care diagnostics. The second is the development of efficient dye-sensitized solar cells for harvesting and use of solar power. And the third one is the fundamental understanding of overdoped superconductors. This is done by the physicists. And as I mentioned earlier, the modeling and simulation component is still in phase 2, supporting the other 3 components in terms of numerical simulations and mathematical modeling. The education and outreach component in this case, the idea of that was to expand our education and outreach activities, but collaborate with other programs. And some of them were LSAM program, the PREM program, the Upward Bound program, and then this ELAC, which is Community College and USC program that we have developed in collaboration with people from USC. In addition, we had 3 supplemental proposals awarded in this phase. The first one in which the chemists are working with Northwestern University. The second in which mechanical engineers are working with UC Davis, University of South Carolina, and University of Kansas. And the third one in which a set of civil engineers are working in collaboration with University of Pittsburgh, with Washington State University, the Department of Water and Power, and Golder Company. These 3 supplements are important for many reasons, and one of them is that we are taking the opportunity of having these supplements to bring in faculty, new faculty, young, talented faculty members to our team, and we do that through these types of supplements. In addition, we can promote participation of underrepresented minorities in STEM via interdisciplinary collaborations. So this phase had 11 faculty originally, and we have added new faculty, 9 new faculty members through these 3 supplements from 8 departments in the College of Engineering, Computer Science and Technology, and Natural and Social Sciences. In addition, we have a project coordinator, a program assistant, a student assistant, and we have had 3 postdoctoral associates throughout the period. The number of students that we have had during this phase is 43, 21 of which have graduated, even going into PhD programs or going to the industry, and I will talk a little bit about that in a minute. The demographics of this center is 70% to 30% male to female ratio, and in terms of ethnicity, about 65% underrepresented minorities, but mainly Hispanics, because this is a Hispanic serving institution. So some of the activities that we have developed along the way are related to long year research projects in the CREST. And this research is carried out either in individual labs or we share some of those labs as well. And this picture at the right showcases some of what we have done. For instance, the experiments and numerical simulations for fuel cells and batteries in the top right, or numerical simulations of engineering systems on the top left. Then we have had some experimental work in materials in the middle left, and then experimental work by the physicists on these couplet materials in the middle right. In addition, the bottom picture shows my former student Joshua Baltazar along with 2 high school students working on a project, on-campus project, in order to develop a placement hard hat that would place freshmen and transfer students into with appropriate advisors. So we have had these long year research project tasks at CIS, along with periodic meetings every week with staff, every month with the leaders of each one of the components, and every 6 months with the entire CREST in order to assess where we stand and where are we going. And also we have had summer research at CIS, and this is a way in which we have been able to interact and do outreach with other students. So now we have partnered with the Upper Bound program to have high school students in our labs and do community service projects with community colleges and USC, with the PREM program, with the LSAM program. In addition, our students are very engaged in the seminar series, And the idea of this seminar series is to provide them with traditional research talks as well as workshop-like talks in order to show them how to apply to PhD programs or how to bring in a panel of PhD students from UCLA, USC, or Caltech in order to share their experience. So the students also participate in national conferences as well as the student symposium type of conference at Cal State LA. Some of the results we have, this center has been very impactful in terms of results. The average number of publications that we have been able to achieve in globally as a center is 29 per year, which is 4 times that of the first year of the center, that of phase 1, which is really a substantial outcome. We have supported 112 students either directly or indirectly through both phases, 54% of which have gone to master's programs or PhD programs, and 46% onto the industry. And when I talk about PhD programs, we are talking about going to premier research-intensive institutions like Berkeley, like University of Michigan. Currently, my students are at University of Rochester, UCLA, UC Riverside, etc., etc. In the industry, our students have gone to Boeing, Northrop Grumman, Lockheed Martin, SpaceX, etc. So we have been able to really make a good impact with them. Just in phase 2 alone, we have published 2 books, 4 book chapters, 54 journal publications in those journals that you see at the right, 26 conference proceedings, 30 presentations, and 8 master's theses or honors theses, in which we have developed novel microfuel cells and batteries, materials that increases the energy conversion from solar to electric, or new models of thermal systems, even going into these fractional order differential equations, which are very novel. In addition, we have been very successful in institutionalizing some of our activities, and 2 of them are very important. One is the seminar in interdisciplinary STEM research. Before the CREST came to Cal State LA, there was no seminar in the engineering, computer science, and technology, this college, and we were not only the first ones to develop it, but also to institutionalize it. So now everybody can take that seminar. And also we partner with the PREM program in terms of institutionalizing and creating and institutionalizing a master's degree in material science and engineering. It was institutionalized in the fall of 2018, and the first cohort of 10 students started in 2019. Some of those students, by the way, I must mention that are funded by the CREST program, working on energy and materials related projects. We have been able to outreach over 500 middle school students. We have had in our labs 50 students in summer research, 40 high school students during the summer. And as Kimberly mentioned, we have learned a lot of lessons along the way. One of them is administrative support, which entails a lot of work in convincing people, trying to establish what is the role of this center in the institution, and that is essentially important. Staff is essentially in operations, and the program coordinator is, of course, essential because he or she knows that all the details about the program, and it can be a big help. We don't have a communications and outreach staff member, but I think if you want to grow the center, that is one area of opportunity that you should explore. In addition, because of the workload of Cal State, the Cal State system, the CSU system, it's important to budget enough assigned time and summer support for faculty this is linked to the to incentivizing faculty to submit proposals, because that's the only way that this is going to be actually permanent. Now, collaborations, internal and external collaborations are extremely important because people bring different skill set and ideas, and that's the way to go when you have a high teaching load. Leverage the CREST is being very successful for us because we found some of the novel ideas, developed the background in order for the person or the set of people to then develop the write the proposal and submit the proposal and hopefully get it. Strategic planning is essentially important because NSF is what NSF wants. NSF wants to have a center that goes beyond the funding period. Otherwise, it's just for they see it. It's difficult to convince Congress that this is not a waste of time and resources. And increasing efforts to nurture and foster early career faculty is extremely important because it's the way to keep the center's ideas fresh and to expand the presence of the center and even institutionalizing the center. In terms of students, building a pathway for undergraduate students to become CREST graduate students is very, very important for two reasons. We have to start early for well-rounded development, and the second is that productivity and student success increases. So next steps, we are going to continue toward institutionalization of the CREST, and for that we have developed a pilot mechanism with the Office of Research, Scholarship, and Creative Activities, by which 2 staff members are partially dedicated to support operation activities, and this is for 1 year. And also, we are trying to negotiate with the dean in terms of technical support. I would say that the CREST program, the PREM program, the LSAMP, and similar programs that you're going to hear here in this webcast are essential to create opportunities of talented and underrepresented minorities. And they are very, very important if we want to advance this country. So it's important to support them, in particular in STEM fields. Now, I would like to introduce Keith Trujillo from California State University, San Marcos.
Good morning, everyone, from Cal State San Marcos, rainy Cal State San Marcos. It's wonderful to be a part of this webinar where I have the opportunity to talk about our student-directed programs that are helping students get trained in the sciences and moved on to graduate programs that allow them to become leaders in their fields. I'm going to take a slight turn now and go to the National Institutes of Health. Now, if you've been a member of the CSU for any amount of time, you're well aware of the many acronyms we use and the fact that everything is referred to by initials. Well, we've got nothing on the NIH. They use acronyms for everything, and it's easy to get lost in all of this. NIH has 27 institutes and centers, and within those institutes and centers, there's many opportunities for funding undergraduate research and training. Now, I'm going to draw your attention to one institute in particular, the National Institute of General Medical Sciences. I wouldn't have the time or the opportunity to cover all of the undergraduate opportunities at the NIH, so I'm going to focus on this one because this has been a long-time source of funding for increasing diversity in biomedical and behavioral sciences at the NIH with programs that are really targeted to the CSU and similar institutions. So drilling down just a little bit further, within NIGMS there are several divisions, and the division that we're most interested in is the one at the bottom here, the Division of Training, Workforce Development, and Diversity. You can see that their mission supports programs that foster research training and the development of a strong and diverse biomedical research force. Now, some of the programs that they have there are ones you've probably heard of due to their being instituted at many Cal State universities and other institutions that do similar work. The RISE program, the MARC program, the Bridges programs, there's a couple of those, and the Prep Baccalaureate program. I'm going to talk a little bit more about those going forward. We've been very successful at Cal State San Marcos over the years in being funded by these NIGMS TWD programs. So some of our programs have focused on juniors and seniors. So there's aimed at preparing those students that are most advanced to have that additional preparation that will allow them to go on to graduate studies in the biomedical and behavioral sciences. So the first of these programs is MARC, the Maximizing Access to Research Careers program. As you can see, I've got T34 next to that, and I'll talk about that in a moment. And the other program is the RISE program, the Research Initiative for Scientific Enhancement. And you can see that, the initials for that are R25. So the T and the R refer to the type of grant that supports these programs. T refers to training programs, and R refers to research programs. And the R25 in particular is a research education program. So you need to pay attention if you have an interest in applying to these programs, because the requirements are a little bit different for each. And the T programs offer a little bit more, they're a little bit more prescriptive in the way they want you to implement the programs. And so you'll find that writing these grants can be a little bit easier in one way, and that they tell you what they want to hear, but can be a little bit more difficult in other ways, because it's very difficult to be innovative and creative. But overall, the goal of these programs is to increase the nation's pool of students from underrepresented groups who have the research experience and science preparation to matriculate and succeed in biomedical PhD programs. Now, again, we've been funded for about 20 years from the NIGMS TWD, and another program we have is has a focus on freshmen and sophomores at the community colleges, and this is the Bridges to the Baccalaureate program, which is a T34. And so what this program allows us to do is reach out to the community colleges, recruit students there, and help them prepare for transition to four-year universities in the biomedical and behavior sciences. And our partnership is with the two local community colleges that are near us, Palomar and Miracosta College. Dr. Denise Garcia in our biology department is PI of this program. Over the right, you can see one of our former students, Sharon Petre, who's now at Johns Hopkins University. The goal of the Bridges to the Baccalaureate program is to prepare a diverse cohort of community college students to transfer to and complete a bachelor's degree in biomedical research fields. So you can see there's a lot of overlap between the goals of the RISE MARC and the Bridges program. Now, something, if you've paid attention at all to what's going on in NIH, you've noticed that there's a changing landscape there within the TWD program at NIGMS. We are no longer eligible for MARC. MARC is now reserved for research-intensive institutions. So most CSUs can no longer support a MARC program. And because of these changes, there's less money, less training money available for the California State University institutions. So in this changing landscape, there's a new program that's been developed called the URISE, which is a T34 program, which replaces the RISE program. And this is reserved for non-research intensive institutions like California State Universities. The goal of the URISE, similar to RISE and MARC, is to diversify the pool of students who complete a PhD degree in biomedical research related fields. So just to summarize what we've been able to do over the past 20 years is we've had a lot of student success that we're very proud of. We've trained hundreds of students, really, been able to touch many, many students here at Cal State San Marcos, and more than 300 have gone on to pursue graduate studies. You can see as of 2019, we've sent over 300 students to master's and PhD programs, including a majority going to the PhD programs. These students have all been from underrepresented and or first generation and or low income groups. So you have a tremendous opportunity with these programs to take students who probably wouldn't have dreamed of going on to master's or PhD programs and preparing them for that. Here's another example of our student success. In our office, we've got this map over on the right where we're placing the photographs of students that have gone on to PhD programs and where they've gone on to. And you can see that we've sent our students to top programs nationally. at Harvard, Yale, Stanford, Johns Hopkins, Michigan, several of the UCs, several of the University of Texas, and various other institutions around the country. Dollars is also a very important part of this because it is expensive to run these programs. You do need institutional support. You do need the support of your administration, but you also, oops, slides are jumping around. So you also need that funding in order to support the training programs for these students. So through Rise, Mark, and Bridges, we've garnered about $19 million over the years. And this goes to financial support for the students in the form of stipends or salaries. And that's a very important thing when we talk about the student population, because many of them are out working in the community at low-wage jobs. And we're able to buy them out of those jobs and put them in the research labs to help them prepare for the graduate studies in these areas. We offer academic support so they can be successful in their classes. We offer career awareness and guidance to help them find their way to the PhD and find the programs at which they can be most successful. We offer research opportunities, and that's very, very important because that's what graduate programs want to see. And through that, it's very important that we have the collaborations with the faculty on our campus who train these students in their research labs and write letters of recommendations. And so it's a very important collaboration that the training programs work with the faculty at the institution. And then we offer assistance with grad school applications, so students aren't working blindly in applying to these programs. And we work real heavily to help them find those institutions at which they can be most successful. Not necessarily aiming for the very highest prestige institutions, but the institutions at which these students feel most at home and get the most support that will allow them to be successful. So, among the lessons learned through all of this is that NIH does have programs that are targeted to CSU-like institutions, so don't be afraid to go after these. These are institutions that serve students from underrepresented groups, and through these programs we can prepare students to succeed in graduate studies and become leaders in biomedical sciences. Now, another lesson that we've learned is it does help to consolidate these programs. These programs that I'm talking about are housed in an office that I'm director of, the Office for Training, Research, and Education in the Sciences. And through that, we have the opportunity to collaborate and mix and match students across these programs and offer the greatest support. And it also helps to offer a comprehensive approach. Among the programs we have include those that come in from NIH, but also from National Science Foundation and the Department of Education. And so by putting this all together, we offer financial support, academic support, career awareness and guidance, research opportunities, and assistance with applications that allows the students to go on and be very successful at the next level. So, next steps and long-term plans. So, URISE has been on our radar since we first heard about it. And as I wrote when we first made this PowerPoint, we were very optimistic for funding beginning in 2020 because we got an excellent score from the reviewers. Since that time, I've learned that we will indeed be funded by URISE, and so we're very excited about that. We'll be recruiting our first cohort and starting them in June of this year. We will continue to support our Bridges to the Baccalaureate program with continued funding from NIGMS through 2023. And we are going to look into the Bridges to the PhD program that will allow us to prepare master's students on our campus to go on to PhD programs. And so we plan to submit a proposal in, I think it's September of 2020, in collaboration with some of the local UC campuses and other research institutions in the area. And of course, we're going to look to other NIH funding opportunities in order to expand all of this and make sure that we can do our best for the students here at Cal State San Marcos. So to summarize all of this, NIH is a great source of funding for CSU campuses. It allows you to prepare students for graduate studies and careers in biomedical sciences. There's also a lot of research support for faculty at the NIH, and that's a whole other talk. So I'm not going to talk about that now. But many of you are aware of R15 grants and SCORE grants that can fund the faculty at your campus and allow them to be successful in research and through that train the students on your campus. NIGMS and the TWED division in NIGMS is a major source of NIH undergraduate funding, and you should look to that if you're interested in pursuing this and have a good cohort of biomedical scientists on your campus. It's also important to be aware that the landscape at NIH is changing and probably will change over years to come, and so you really need to be nimble and responsive to change, pay attention to what's coming out in the program announcements, and you need to prepare early and pay close attention to program announcements as they hit the ground. And so with that, it's my pleasure to introduce Alex Rudolph from Cal Poly Pomona to talk about his programs.
Good morning. I would like to add my thanks to Frank Gomez and the STEMnet team at the Chancellor's Office for organizing this wonderful webcast. So I'm going to talk about a program known as CalBridge, which is a collaboration between the CSU system, 16 actual CSU campuses altogether, and 9 of the UC campuses to work on promoting students going on for PhDs. And in particular, we're focusing for the moment on physics and astronomy, my own fields, but we are contemplating expansion, as I'll mention later, into other areas, including computer or information science. And the goal, as you can read, is to just increase the number of students from traditionally underrepresented groups doing those, completing their bachelor's and going on for PhD degrees. Now, physics and astronomy are much smaller than the biomedical and other biological sciences that have been discussed earlier, and even compared to some of the material science work. So one of the reasons we went for a multi-campus approach was because no single campus tends to have enough numbers of students to support a major effort like this. So one question that we get asked is, why do we focus on graduate programs? I know a lot of the efforts at the CSU is, of course, appropriately centered on helping students complete their bachelor's degree. But if you look at diversity in the STEM fields, PhD programs are even more undiverse than at the undergraduate level. And students who get PhDs do actually end up with often higher paying and more satisfying careers than a simple bachelor's can give them. But probably one of the biggest motivations is that if we want to have a more diverse faculty at the CSU and other minority serving institutions, or just in general, we need to have a more diverse PhD population. So until that's addressed, we won't be able to ever increase the faculty, the number of faculty from underrepresented groups. And many of the things that, as you'll see, are the solutions we found to support a program like this are actually very similar to ones that are being used at the undergraduate level and can help at that level as well. So this probably doesn't need too much emphasis with this group, but this is just showing some of the statistics for women and underrepresented minorities in getting PhDs in various disciplines. Women are actually doing fairly well in STEM in general at almost 50%. But if you go over and look at the orange bar, which is physics and astronomy, or computer science or engineering, it's much lower, more in the 20% range. With underrepresented minority students, if you look at the U.S. population, is about 31%. Actually, that's a bit low because that's from a few years ago, and it's increasing all the time. But that's roughly the number that you would of the population that is represented by those groups. And again, all of STEM is doing about 15%, just a little less. But physics and astronomy is much worse, as are the other fields that we're sort of targeting. So we have a serious problem in physics and astronomy with underrepresentation that's quite severe. And that's what we're trying to address. So the CalBridge program is in a collaboration, as I mentioned, of physics and astronomy faculty, over 150 faculty, from a total of 16 CSUs and 9 UCs in the network. And the goal is to make this open to all of the CSUs. We started with the ones that we did because, as you'll see later, we do include in our program workshops in which students are in person meeting together to be able to have a chance to build a cohort feeling across campuses. And so we stuck with campuses that were within about a 2.5 hour drive of the major metropolitan areas in Southern and Northern California. But we're actively working on ways to incorporate more far-flung campuses as well. So the 16 of the 23 CSU campuses does represent about 80% of the CSU undergraduate population, so we're reaching the majority of the CSU students through this program. And the 9 UCs represent all of the UCs that have physics PhD programs. The UC San Francisco does not, so that's the only reason they're not included. So what is CalBridge? And I want to point out that this is going to match very closely with what Keith Trujillo does in his program. And it's interesting that we converged on a similar set of support structures for the two programs, which I think speaks to a couple of things. It really requires a broad portfolio of interventions to be able to make an impact on these problems. So starting on the left, we have well, first of all, CalBridge is a 3-year program. So what we do is we take students in their junior year. As they enter their junior year, we support them for their last 2 years of undergraduate work, and then potentially into 1 year of graduate work if they attend a UC. The undergraduate, the choice to intervene starting in the junior year was based on the experience we had that students in physics majors often stumble academically when they reach the higher level courses in the junior year, and so we felt that that was where the intervention would be most effective. So what do? We provide 4 main pillars, as we call them. Multiple engaged mentors, and by that I mean each scholar who's taken into the program is actually given 2 mentors. They get a mentor from their home CSU campus, but they're also given a mentor from one of the UC campuses, and that's one of the main ways in which the UC campuses are participating. That is, UC faculty are voluntarily mentoring CSU students for 2 years of undergraduate work. Those mentors meet with their scholars at least twice a month and really mentor them not so much in research, but in just all the issues that come up as one tries to work their way towards going on for a PhD. So they talk academics, they talk anything personal that's affecting them. They're helping them figure out what resources they need to be successful. And so that very intensive mentoring has been a very big part of why the program has been successful. And when we survey the students through our independent evaluator, mentoring is mentioned far and away as the most important factor for their success. We do offer scholarships of up to $10,000 per year, and as Keith mentioned, this is critical. Many CSU students work 20 to 30 hours a week or more, and that's one of the major factors that impacts their GPA and makes it much harder for them to be competitive for graduate school. When we offer them this money, in exchange they sign a contract in which they agree to work no more than 10 hours per week throughout the 2 years they're in the program, and that allows them to effectively focus their energy on their schoolwork and other factors that matter for them getting into graduate school. And the third thing we provide is what we call professional development workshops, which are sort of, and those are the workshops that take place generally in person. And what we do with those is the scholars from a region, either north or south, will come together, typically on a UC campus. And so these workshops have a couple of goals. They have the goal of helping students learn some skill or some information that they need to be successful. And I'll mention briefly in a moment what some of those workshops are. It also provides a chance for them to meet each other in person and build a sense of community across these campuses so that all of them feel like they're part of the group and they're part of a larger group. As I mentioned, physics and astronomy is quite small, and so often there's only maybe 1 or 2 or a dozen or half a dozen students at any one campus trying to go on for a PhD. This allows them to be part of a much larger group of like-minded students that are across the CSU who have similar goals. Some of the topics of these workshops include we do a little bit of Python programming because that's such an essential skill we want them all to have. But we also do things, we also have workshops on what we call socio-emotional competencies, covering topics like imposter syndrome or growth mindset. And finally, and probably most importantly, is we have 2 workshops that are in the spring of the junior year where students begin the process of thinking about applying to graduate school. We present information about what graduate school is about, and we help them start brainstorming how to write an essay, and then we help them start brainstorming about what they're going to write in an essay, and they actually write a draft in the spring of their junior year, and then bring it to the second of the 2 workshops to review and revise that as a starting point to working on that essay and throughout the summer and into the fall. And having that head start has been also very critical to the scholars being quite successful. So I'd like to take a moment to pause and show you a very brief video in which some of the students talk about the importance of the program to them and their success.
I've never felt like I've been alone at any point during my journey here. Having mentors pushed me to want to be in their shoes someday so that I can inspire some students that might be going through a rough patch or even just loves it as much as I did, so I can maybe even see myself in them.
The mentoring with both my Cal State mentor and my UC mentor was amazing. Like that, I think, was the highlight of the program for me, and I don't think I would be where I am today without their mentorship.
I was brought here to the US when I was 10 from El Salvador. And so I'm an immigrant child, and that means I'm a DACA recipient, and which means I'm also an AB 540 student. So it means I don't really have too many resources available to fund my education. Right now I'm in Calbridge because I want to maximize my likelihood of being successful in grad school. So I think they're preparing us very well for it. They give us workshops, they train us on how to write our personal statements, they tell us about the grad school application process, and we get to work with UC faculty as well as CSU faculty, and they're all very closely mentoring us through this very slippery path that it's very easy to fall through the cracks.
So as you heard, the scholars feel that the mentoring and all the other support structures are very important to their success. So let me talk briefly about that success. So we've had 6 cohorts with a total of 99 scholars, and to this point, 4 of those cohorts have applied to graduate school, and we've had an 82% acceptance rate into PhD programs directly from undergrad. About 70% of the scholars are from underrepresented minority groups. A little over 2/3 are from first-generation college students. A little less than half identify as women, and one thing we're particularly proud of is that almost a quarter of our scholars identify as underrepresented minority women, which is we're a very high percentage compared to the numbers that exist in our field. So our program actually has grown a lot as our funding has increased. Our goal is to, we're on our second, our funding comes from STEM, the Scholarships in STEM program. Our first STEM covered the first 4 years you see on this graph, and then we've expanded under the new grant, which is a $5 million level 3 STEM, and our goal is to have 40 to 50 scholars per cohort graduating, and the majority of them going on for PhDs. And in terms of impact, so just to give you a sense of how small the numbers are in physics and astronomy, this chart on the left shows the percentage of PhDs that get STEM students who get PhDs, which is that 14% I showed you. Physics is on the right, showing a little over 6%, but that 6% of underrepresented students getting PhDs only represents 80 to 100 PhDs per year nationally going to underrepresented students in physics and astronomy. So by adding 40 per year to that number, CalBridge can actually add to that by 50%, as much as 50%, which is a huge impact on a national level. I want to mention that we have plans to expand into other STEM fields given our success, and to help with our sustainability, since we want to show it's a more broad-based program than just one field, and none of our programmatic elements is really specific to physics and astronomy. So this fall we're planning a small pilot in computer and information sciences with just a few 4 to 6 scholars in the first year, which will be led by CS faculty in both UC and CSU systems. And then we'll eventually hope that grows to be a similar size or even maybe larger than the physics and astronomy program. So with that, I'd like to introduce Lisa Hammersley, who will be from Sacramento State.
Thank you very much, and I'll echo everybody's thanks to STEMnet for organizing this today. I'm going to talk to you about the CSU LSM program, or the California State University Lewis Stokes Alliance for Minority Participation Program. Let me just advance the slide. Okay, just as a quick overview, this is a program that's been around for a very long time. It was established in the 1993-94 academic year, and since then served, at this point, more than 27,000 students. The program is jointly funded by NSF. They fund us at about $800,000 a year, and the CSU Chancellor's Office matches that for $800,000 a year. We're currently in our 6th funding cycle, each is 5 years long, and those are NSF funding cycles. And we're just in our 2nd year of the 6th cycle now. When we started out, we were an alliance of 18 of the CSU campuses, and we're now an alliance for all 23 campuses. We have 3 primary goals. One is to increase the number of undergraduate degrees awarded to, in STEM awarded to underrepresented minority students. And then we also have a second goal of increasing the number of underrepresented students progressing to graduate programs in STEM. And this is sort of representing an arc with NSF. We started off very much focusing on academic interventions to increase retention and graduation at undergraduate level. And we've since added programmatic elements that are focusing on moving students forward into the graduate programs. On top of that, we've also had an increasing focus on disseminating best practices in broadening participation. And this most recent grant includes a specific broadening participation research project, which I won't be talking about today. I'm just going to talk about the main programmatic part of LSM. As a quick overview, so we serve approximately 3,000 students a year. And on each of our campuses, the program varies a lot. So we have some programs that are very small with only about 20 students. And then other programs are really large, like Cal State LA, I think, is our largest program. We have varying levels of campus support. That could be in the form of a space or some extra time or a portion of some staff members' time. And the administration of the program varies by campus. So given that, we've got a whole bunch of campuses, and I've got a complicated graph there that shows that we have each of our campuses, on each one is a program oversight, program coordinator who coordinates the program, the sort of student-sided program. And they all report directly to the statewide office, which is here at Sacramento State. We have a program oversight committee made up of 5 program coordinators. And then we have an external evaluator, and we have our grant administration office here at Sacramento State, and the budget offices at all of the 23 campuses. So it's pretty complex, and one of those things is, well, how do we maintain a strong and cohesive alliance as opposed to just a bunch of independent programs being funded piecemeal? We do that by implementing collegial decision-making, and we have a programmatic structure that allows our campuses to be flexible in how they provide the programmatic element, but also keeps some consistency. In terms of activities, we offer a whole range of activities to students. These are all sort of evidence-based, high-impact practices. And NSF has sort of divided them into 3 areas, and we offer all of them. We have a kind of academic support side, which is supplemental instruction or peer-assisted learning programs, summer bridge programs, other programs that help transition students either from as they transfer in or as they become a new science major, or even for freshmen. And then we provide some support with textbooks. We also do what NSF calls professionalization programs, which are looking forward to graduate school. So these are research activities and internships, international research activities, and we run 2 international programs funded centrally through the grant. We support presentation and publication of research by the students who are participants in our program. We have a range of graduate school preparation activities, including travel to grad programs. And then students within the program have the opportunity to take leadership roles as a facilitator, a peer mentor, or a trainer of other students. And then there's this other component that NSF refers to as social integration, which is not my favorite name for it, but this is really about the area of helping students feel, especially underrepresented students, not feel part of the scientific enterprise professionally and socially. So we provide advising that is focused on careers, a lot of communications with students, Facebook pages, a lot of peer mentoring. We send students to conferences where they don't have to present, and some of those might be things like the Graduate Diversity Forum. And then we have activities that are really around, we call them cohesion activities, and that's mostly to do with NSF and funding of sort of social activities. But these would be things that bring students together at the end of the year to celebrate their achievements. Our campuses, in terms of flexibility, there are 3 things on here. We allow campuses to identify where their biggest need is. Each of our campuses is very different, and we have a wide range of activities, and on many of our campuses, those activities exist either funded by a different entity or have been institutionalized over the years. So we allow a campus to identify as academic preparation, where their main emphasis is on those academic support activities. And then we have campuses that identify as professional preparation, and they're more likely to be a research-focused project. And we have some of the campuses that joined us very late in the Alliance that really came in just with a pure research, student research focus. And then we have a lot of campuses that do it all, and so we call those the dual emphasis campuses. And we have different expectations in terms of outcomes for them, for each of these. So when we're looking at outcomes for academic preparation, we're looking at retention and graduation rates. Professional preparation, we're really looking for students moving on to graduate programs, and dual emphasis, we kind of expect it all from them. We have a whole series of short and long-term objectives. We've just finished up phase 5, our 5th cycle of funding, so I have the final results here. I'm going to skip through these really kind of quickly for the sake of time and move to the more impactful results. So these are some of the short-term ones where we looked at the numbers of students that we would be supporting every year. Like I said, we're around 3,000 students. We have about 800 of those in supplemental instruction. You can see those numbers going down, and that really reflects the fact that our campuses have really been institutionalizing supplemental instruction. So it's not really an activity that LSAMP is supporting financially at the moment. We have students, about 300 in these transition programs to help transition them into STEM programs, and about 1,000 students a year that we're engaging in professional development activities. We are engaging about 800 students a year in research activities, either funded directly by LSAMP or where we've assisted the student to get into a program like an REU. And we're supporting about 40 to 50 students a year in international research experiences. And what we found at the end of the 5-year period is we had set a series of short-term goals in terms of numbers of students, the amount of activity we would do, and we met every single one of those. Our long-term goals were looking much more at persistence and graduation rates, and looking at the number of students going on to graduate programs. And of course, we have 20 years of data here, so it's kind of a rich data set for us. What you're looking at are graduation rate graphs. Well, the one on the left is for looking at Latinx students, and the one on the right is looking at outcomes for African American students. If you just look at the two lines and don't worry about the bar chart, the red line is the graduation rates, 4, 5, 6 year, 7, 8 year graduation rates for non-URM students who are not part of the LSAMP program. And the darker line, the blue line and the green line, those represent the graduation rates for Latinx for blue and African American students in green who are not in our program. So the gap between those lines shows the equity gap that this program is aimed at closing. The bars show the outcomes for participants in our program. So on the left, you can see that our Latinx students, our graduation rates are much closer to those for non-URM students. And for African American students, we've made progress in sort of closing the gap by 50%. Obviously, that's something we're still working on, and data sets like this show us where our efforts need to be. Up on the right, you can see a box. We've been tracking the number of our graduates over the years from all of our programs that have moved on to graduate programs in STEM, and 41% of our graduates matriculate into graduate programs, which is a very high rate relative to national rates to all students, and then especially national rates for URM students. So I'm really proud of that. In terms of our results, we have if you just look up CSU LSAMP online, you'll find we have some publications. On the right is our 2015 impact report, which we prepared for the NSF. And on the left is our proud publication, which we do every year as a digital publication that features students from all of our campuses, outstanding academic achievements, outstanding research achievements, outstanding alumni. And then we also feature other items with the Alliance as a whole as a way to promote what we're doing. Some of the things we've learned with, I think, 26 or 27 years of working through this, though I've only been involved for 10. We have 23 campuses and 2 sources of funding, NSF funds and Chancellor's Office funds. We're really complex. We have my office deals with about 50 separate accounts as we try and track the spending for each campus from each fund. It takes a lot of effort to maintain a cohesive alliance and to ensure that we're being in compliance with all fiscal policies, our NSF policies, our CSU policies, state fiscal policies. So we have to provide a lot of central oversight to make sure that we are charging things correctly. We found over the years, we've tried different models, but this one that we're on right now, it seems to be working very well, where we're allowing our campuses to leverage the resources they already have and provide our resources in the places they most need for their students at this time. And we found that when we are all doing the best thing for our own students on our own campuses with these sort of collective approaches built in as well, our collective results are great. So we're pretty comfortable with the way this is working. I'm always thinking about the long-term plans for CSU LSM. We're in our 2nd year of 6 5-year award from NSF, which is pretty amazing. NSF doesn't do a whole lot of continuing awards like this. We're unsure if we'll be allowed to apply for a 7th funding cycle. It's been 30 years at the end of this. And we're talking about $800,000 is the cap. We might actually do better by splitting into a couple of smaller alliances or including some community colleges to be able to have multiple alliance grants. And then, in terms of GI 2025, I think it's interesting to look at programs like these and some of the other ones that you've been hearing about, where there are a fair number of similarities, and ask ourselves, where do we fit in the context of GI 2025, and how do we take these known practices that are working and scale them up at an institutional level. So in summary, we've been around for a long time. We have data that shows that we are increasing persistence and graduation rates for our participants in our program. We're above national rates for year-round students going on to graduate programs. We base this in the fact that we are comprehensive. We do it all. There's no magic bullet. It's not just research. It's not just academic support. It's all of those blended together at the point in the student's career where they need each particular piece. And, it's time to consider the future of CSU LSM and to see how much of what we do could be institutionalized, scaled up, or folded into other programs. I do think there's a place for CSU LSM. I always ask this question because I think it's important that we always be thinking about the next thing. And with that, I think that's it. It is my pleasure to introduce Nicholas Cusis, sorry for pronouncing that right, from CSU Northridge.
Thank you. So my name is Nick Cusis from the Department of Physics of California State University in Northridge, and I'd like to give you an overview of our NSF-funded partnership in research and education material science with Princeton. So this started in 2006. So we were renewed in 2012, and then we were renewed in 2018. So we have about 18 years support from NSF under this program. So what is the vision statement? The vision is to establish a joint research powerhouse on quantum materials and to increase the recruitment, retention, and degree attainment by members of underrepresented groups in material research. High-quality research is one of our goals, and success of minority students is a priority. So the intellectual merit, the PREM aims to address fundamental problems in quantum materials that have vital scientific and technological importance, as well as economical and societal impacts. So the PREM consists of 3 interdisciplinary research groups. So the first interdisciplinary research group 1 involves quantum materials and topological materials, including spontaneous fractional topological quantum Hall effect in frustrated materials, fractional topological physics in periodically driven systems, and detecting fractional statistics for quasi-particles in interaction-driven systems. The second interdisciplinary group involves electronic excitations energetics and dynamics in quantum materials, including two-dimensional semiconductor heterostructures, organic materials for single fission, and 2D hybrid perovskites for photovoltaic applications. And then there is a C project which involves surface science and defect physics, which are relevant to photocatalytic splitting of water on oxides and 2D materials. So the broader impact, the PREM is committed to enhance broader participation of underrepresented groups in material science and education through the following thrusts. We have multi-pronged recruiting strategies to attract students from underrepresented groups, summer programs for research training of undergraduates and high school teachers at the Princeton Complex Center of Materials, organization of materials and nanoscience camps for high school teachers, organization of distinguished lecture series, PREM seminar series, and annual PREM research symposium, establishing partnership with industry and national labs for student training and internships, material science day, and finally curriculum development. We have developed a set of courses on quantum materials and data science. So the people involved, the faculty involved from CSUN is Gang Lu, who is the PI on computational materials theory. It's Donna Sheng in the first thrust, myself in the first thrust, Xu Zhang in the second thrust, UC Loranta from chemistry in the C program, Aziz Boulezba on the second interdisciplinary program, also from physical chemistry, and finally Li Gao, who is an experimentalist in condensed matter from physics, who is also in the C program. The faculty involved from Princeton involved Duncan Haldane, who is the Nobel laureate a few years back in condensed matter theory, Grace Scholz, physical chemistry and experiment, Lin Lu on chemical engineering, Fuan Ong in condensed matter experiment, Annabella Soloni in theoretical chemistry, Ali Ghazani, who is the director of the Princeton Complex Mercek Center in condensed matter experiment, and finally Daniel Steinberg, who is the director of education and outreach at Princeton. Now, our current PREM students include Eric Guzman, Fernando Ramirez, Nick Carrillo, Kathleen Vaughan, Vanessa Lopez, Jack Noturi, Juan Gomez, Vanessa Carvajal, Vilman Lopez, and Malcolm Jackson. I should say Malcolm Jackson just started his PhD program in UCLA. I'd like to highlight another student really who started with us in 2007, way back. So he got his PhD, so that's Jacob Gales. He received his PhD with Hiroshi Nova in Texas A&M, and then he continued his postdoctoral studies with Claudia Felser in Max Planck Institute at Dresden. And recently he just emailed us that he got a faculty position in University of Southern Florida, and we're really very proud of his accomplishments. Okay, so now in terms of research experience for undergraduates, each year we have about 5 CSUN students. The students have opportunity to participate in interdisciplinary research, which is supervised by Princeton faculty and graduate students in different departments on both theory and modeling and experiments. Interaction with REU students all over the country, providing wonderful experience for students. So we have about 30 PREM students which have participated in REU program at Princeton. I don't have a slide, but I should say we have about 20 to 25 publications per year. And these are some of them in very high impact journals such as Science, Nature Communications, and Physical Review letters. And some of these are co-authored with students. Now, in terms of outreach, we have organized a workshop series on nanoscience materials research for high school teachers since 2012. The goal is to inform high school teachers of the progress in quantum materials and nanoscience research at CSUN and elsewhere. The program consists of lectures, tours to the state-of-the-art nanoscience research labs at CSUN, and hands-on activities of fun experiments. So we have toolkits from Northwestern University where the students can actually build on in-house type of devices, for example, nanotubes, and which has been a lot of fun. So the teachers also have provided with instructional material, which they can disseminate in their classrooms. Plans for recruiting local high school students into the science programs at CSUN are also discussed. And that's it. So I would like to introduce our next speaker, Fran Gomez, who is going to be the moderator in discussion.
Thank you, Nicholas, and everyone for your presentations. All these projects are outstanding and demonstrate the diversity of work occurring on our campuses and student involvement. We now have a little bit of time for some Q&A between the registrants and all of our presenters today. And as we wait a little bit for them to come on the screen, I certainly would encourage everybody to participate by providing, certainly on the open chat line, as well as to continue engaging after with presenters. We have a number of questions here, and I'll be going through them one after the other. Here's one that I think is kind of up the alley of both Kim and Tim. How have you used the grant, your CREST grant, to assist junior faculty members?
Go ahead, Tim.
So as I sort of alluded to at the beginning, our newest member is Dr. Sarah Calori, and part of the recruiting effort to recruit her involved the CREST program. So having the CREST program, I think, enhanced our abilities to recruit her. Also, it provided her with a research group that she could immediately come into and get plugged into what the research that was going on. And she's benefited from that and has been the PI or co-PI on subsequent grant awards. And I think in our CREST 2, we actually specifically incorporated the idea of bringing in not only new faculty to the campus, but maybe mechanisms by which we can bring in existing faculty that are already on campus into our research group. So I think these institutional grants are absolutely wonderful from both sides of things.
I'd like to add that we're in the process of hiring a material scientist right now and having some funding already for equipment and a group to work with. And one thing you didn't mention was that we also got a CREST supplement to help support Sarah's work as well, and incorporated her into our partnership with UNL. So our new faculty hire, this has been a real selling point for the current search, and has helped Sarah as well. Thank you.
Thank you, Kim and Tim. Here we have another one, and this is probably up Arturo's alley since it refers to your CREST Seas program. How has the CREST Seas program benefited other programs and or attracted more and other type of funding?
Yes, this is an excellent question, I think. Well, one of the main aspects is we have been able to successfully collaborate with other programs, and one of them is the PREM program here at Cal State LA. We have also collaborated with the LSAM program as well in order to provide projects for students and access to labs, etc., etc. In terms of the PREM program, we were able to jointly develop this Masters of Science in Material Science and Engineering, which is a major outcome from our grant. And not only that, but in terms of other donations, for instance, that we have obtained, based on ideas from our center and outcomes from in terms of research, in terms of student development, instead of faculty development, because we did something similar to what Kim and Tim are doing, which is use the supplements to bring in people, and we have brought nine people into our CREST. We have provided mentoring to them, and they have been effective in starting to write proposals and getting funding. But one of them is definitely, I would say, in the College of Engineering, Computer Science, and Technology. We have obtained a couple of donations from the SICAN family. One of them is a $1 million donation to establish the SICAN Fellowship. And this SICAN Fellowship, the goal is to promote research in sustainability. And this is for faculty development, and particularly for faculty in the early, sorry, my light just went off, for faculty in the early careers. And the second is from the same family, a $1.25 million to establish the SICAN City Center, which is Sustainable and Intelligent Infrastructure Center to support research, education, and professional development on sustainability initiatives. And the idea of this center is to provide managerial support in terms of staff members, potentially a technician, some money for maintenance of equipment, and basically we have developed the first office, the first research office at the college, besides the university office, research office. So I think our center has been impactful in those ways.
Thank you, Arturo. Here's another one. I think this is up Keith's alley. Now that the MARC program is reserved for R01-like institutions, does the URISE program offset these funds? And if not, how might institutions like the CSU make up for this decrease in future grant support?
So, yeah, one of the problems with the changing landscape at NIH is that they've reduced the dollars that are available for these training programs with the implementation of the URISE program. So one of the things that they're expecting is a lot more institutional support, which makes it imperative to really talk to your administrators on campus and get that institutional support wherever you can. So unfortunately, it's not a real easy nut to crack to figure out where else you might go to pick up funding to help support the students. But there are other good programs at the NIH, as well as programs at NSF and Department of Education and other federal agencies that you can go to find support for programs such as RISE, MARC, and Bridges.
Great, thank you, Keith. I think we have time for maybe one more question, and perhaps Alex can address this one. Do major institutional grants need to be initiated and led by VPs or presidents, or can others facilitate those proposals and even be led with the VP president support?
Well, I absolutely you can start these types of programs without initiated by faculty. In fact, I don't know if all of our programs are like that, but certainly our program was entirely bottom-up. Faculty initiated the ideas. We put together the network of faculty. We decided what the structure would be like. Now, when we got to a larger size, when we were applying for the level 3 STEM grant, we were required to then bring in administrators at the higher level, mostly deans and graduate deans at the UCs, to show the institutional support that was needed to make the expansion successful. But certainly to start a program like these, I would say my feeling is it's probably better if it comes from the faculty and is initiated by the faculty. And it's possible that getting institutional support earlier might be a better way to go, depending on what your goals are, but certainly it is possible.
Thank you, Alex. That's about all the time we have in terms of questions. The speaker information is available now, and I encourage the registrants, if they have some time, to please contact them, as this could be a great entree to both potential collaboration as well as proposal opportunities. In addition, a link to the webcast will be soon made available. As for next steps, Well, firstly, I'd like to first thank all of our speakers and presenters for giving of their time, and certainly during the time now that we're currently living under. Before we wrap up this webcast, we do have two announcements to make. Please join us on our private CSU STEMnet Facebook group, where we'll answer the questions submitted during the registration period, and where the presenters and I will be available to answer additional questions not answered during the live webcast. In addition, we'll be emailing a feedback survey to you all later today. Please take a moment to respond, as your feedback is very valuable to us. Lastly, I hope you'll consider joining us at 10 a.m. on Wednesday, April 15th, Tax Day, so you won't forget that, for our next webcast on inquiry-based learning. You can contact Monica Alarcon at malarcon@calstate.edu or myself at fgomez@calstate.edu for further information. Until next time, have a great day.